It's a pleasure to be with you, although it's not in person. It's kind of sad. I actually grew up in Swindon, which is sort of just up the road, so it's sort of strange to be in Indiana presenting to people in Reading, or not in Reading, wherever you are. The paper I'm talking about today is called Cognitive Skills, Strategic Sophistication and Life Outcomes, and this is joint work with Eduardo Fay, who's at the University of Manchester, and David Gill, who's here with me at Purdue University in the Midwest. So I'm going to start with some super big picture motivation, which is that there's a lot of heterogeneity in cognitive skills. And by cognitive skills here, we mean like the standard measures of IQ you probably come across, but also broader skills that would also include a cognitive element to them. These are sometimes called soft skills or non-cognitive skills in some cases, and that's kind of confusing because all skills to some extent are cognitive. But anyway, our motivation is that these cognitive skills vary widely across the population. So if we take the example of IQ, kind of the most traditionally studied cognitive skill, about 90% of the variation in adult IQs can be explained by IQ at around age 11 or 12, so before adolescence. And that's not to say that IQ doesn't increase after you reach age 12, it certainly does. We're just saying that those differences that exist at around age 12 persist into adult life, or like at least 90% of those differences. So given this vast amount of heterogeneity in cognitive skills and the fact that we see persistent differentials in cognitive skills opening up early in the life cycle, we think it's therefore important to understand how these cognitive skills, which are established in childhood, go on to influence economic behavior, both in childhood and also later in life. And those later in life economic behaviors, in this paper, we're going to call life outcomes. We also think it's important to learn more about how we can improve cognitive skills in childhood, given these persistent differentials in cognitive skills are established often in childhood. Now, as I've alluded to already, there are many different skills which go into cognitive skills. In this paper, we're going to emphasize one particular cognitive skill, which is theory of mind. This is something which has been studied massively in psychology, but a lot less so in economics, and therefore it might be a cognitive skill you haven't heard of, so I'll take a moment to define it. Theory of mind is the ability of one person to understand the mental states of other people. This means someone with a good theory of mind is very skilled in understanding other people's emotions, intentions, and beliefs. This is a little different from either fluid intelligence, which is about problem solving, or crystallized intelligence, which is more about having kind of learned some facts. It's more a ability to mentalize and to understand the mental states of others. So as I mentioned a moment ago, theory of mind has attracted huge amounts of attention from psychologists. Just to quantify this, if you do a Google Scholar search for theory of mind, you get around 500,000 search results. To give you some context for that, it's about the same number as results as you get if you also search for risk aversion. And of course, risk aversion is something that's massively studied in economics. Also, just some kind of introspection and kind of blue sky thinking about the world maybe tells you that theory of mind, the ability to understand other people's mental states, is going to be something which is going to be very important to our success in life. Actually, there's a quote here that maybe potentially takes us a little too far, but basically says that theory of mind is what accounts for superior human intelligence, and a lot of the great accomplishments that we have as humans are going to rely on this theory of mind ability. So despite theory of mind being massively studied in psychology, it's much less studied in economics, and therefore we know relatively little about how theory of mind affects economic behavior, and that's going to be the topic of this paper. And actually, our paper is going to have a number of different parts to it. The first part is going to be based on experimental data that we collected on children. The second and third parts, or maybe just call that the second part, are going to be based on analysis of a British birth cohort study that allows us to link theory of mind in childhood to outcomes in adulthood, specifically for individuals in the early 20s. So talking a little bit more about the experimental analysis that we do, we're going to use an experiment on children to study how childhood cognitive skills, including childhood theory of mind, influences strategic sophistication. And there are many economic behaviors that children exhibit, even though they're children, they're still engaging in a lot of kind of economic decision making. So you might wonder why we specifically focus on strategic sophistication. We argue that strategic sophistication underlies a lot of our successes in life. If you think about, say, competing for a promotion or choosing a spouse or thinking about what jobs to apply for or what parts of your skill portfolio to advance, a lot of those decisions are ultimately kind of strategic in nature because you're making them thinking about how other people's decisions are going to interact with your decisions to determine the payoff from that decision. A little bit less abstractly, we can see if we look around the labour market and in various educational institutions, we can see examples where programs specifically designed to foster strategic skills, again motivated by the idea that strategic skills are going to be important for being successful in lots of aspects of our life. In that regard, this is just by way of an example. There's one particular program which is now called Accellium, and this develops is a program which is designed to develop strategic thinking skills through strategy skills, and specifically trying to develop skills in people which are going to be useful in their lives. It's used by management consultancies as well as embedded in the educational curriculums, and many millions of students have taken this program. This is a for-profit company running this program, and they picked out, fostering strategic skills as something which is going to be useful to be taught because it's going to make people ultimately more successful in their careers. In the second part of this paper, as I mentioned, we're going to use observational data. Specifically, this data comes from the ALSPAC birth cohort study. This is actually a British birth cohort study taking as its sample a group of children who were born in the southwest of England, in Avon specifically. Actually, the first A in ALSPAC stands for Avon, and it's followed those kids who were born in the early 1990s through their lives up until they're now in their late 20s. This study is, I think, unique. I kind of scoured the world for data. I think it's pretty unique in measuring childhood theory of mind and following through to adult outcomes, at least, and also having a large sample size. We're going to have several thousand individuals in our sample. Based on this ALSPAC birth cohort study, we're going to study the relationship between childhood theory of mind and a range of life outcomes, specifically social skills, education, fertility, and several labour market behaviours. The last thing we're going to do is to speak to our second motivation, which is to potentially identify interventions which can help to foster theory of mind in childhood. And what we're going to do there is to use, again, the ALSPAC birth cohort study to provide some evidence from a diff-in-diff analysis that school spending can potentially be used to improve theory of mind in children. I see Carl's got a question. Go ahead. I don't hear anything.
Sorry, accident.
Okay.
Apologies.
Oh, an accidental hand. Okay. Does anyone actually have a question? Well, we're paused. If not, I will go on. So there's a whole bunch of literature. This paper kind of is, we've thrown together drawing on lots of different literature, so it doesn't have one particular stepping off point from the literature, but in terms of the experimental games that we study, we look at competitive games and we look at response to intentions. Within those literatures, people have studied the behaviors of children, but have not specifically looked at theory of mind. So there's a lot of work looking at kind of the age gradient of developing strategic sophistication, but not looking at links between strategic sophistication and theory of mind in childhood. Regarding our analysis of the longitudinal data, we're not aware of any previous study that has empirically linked childhood theory of mind to adult outcomes. Okay, that's kind of the end of the introduction. Are there any questions on kind of the big picture of what we're doing before I jump into the experimental design? Okay, so our experimental design, was that another accident?
It is a genuine. It's genuine this time.
Okay, great. Go ahead.
Just what you. It seems remarkable that nobody has looked at it before. Could you maybe? Do you have any explanation for why that's the case?
Um,
It's a vague question, I know, I'm sorry, but
yeah,
it seems remarkable.
So, as I say, theory of mind has been kind of originated in the psychology literature. And I think the focus there has been on, it's mostly in developmental psychology. So if you take a kid who's aged like 2 or 3 or even 4, they don't really show any theory of mind. And then there's a kind of discrete change in theory of mind where children start to understand the false belief task, which is basically someone being able to understand another person's beliefs are different from their own. And then later on, children develop more kind of sophisticated types of theory of mind. So a lot of literature in psychology has been all about, how does theory of mind evolve through childhood? And I think it has been natural to then think about the consequences of theory of mind. There's also just kind of brute force of data limitation on this. As I said, we looked high and low to find data on this and found it in this ALSPAC sample, which even being a British person from the southwest of England, born almost at a similar time to these people, I'd literally never heard about before. So there's not a surfeit of data on this in the same way there is kind of longitudinal information about personality and locus of control and the other kind of non-traditional cognitive skills that we've been interested as economists.
Okay. Is it something that you think current cohort studies are building into them? Recently set up cohort studies?
Not as far as I know. So the Millennium Cohort Survey had one question on theory of mind, actually had the false belief question, and I think they inadvertently garbled their experimental instruments. So maybe that's one indication that people are getting interested in this. I think because the way to research in this field is mainly in psychology, psychologists aren't typically involved in designing these studies. They were in their own lab with their own samples, and so we're not really getting input from psychologists. A lot of the longitudinal surveys in Britain are great in that they're quite interdisciplinary. They mix economists and sociologists, and even there's a lot of politics researchers involved in collecting questions about attitudes and voting and so forth. But we don't go as far as to draw on psychology or any of the medical sciences. So I think there's probably still a gap that's there. And the US in general is always a lot less kind of, a lot more straight-laced about their longitudinal surveys. So it's even less likely you're going to see these things popping up, say, in US surveys.
Okay, great, thanks.
And I see another question, Stephen.
Hi, yeah, thanks. I'm simply wondering, so I'm not very familiar with this theory of mind. So I can think about some sort of, let's say, nature type of abilities from the start, right? One would be that you have some sort of emotional, in this theory of mind, some sort of emotional intelligence, as in I can empathize very well with someone's emotion. Another one would be this strategic type of one, where you kind of can understand sort of how other people might act, let's say in an economic sense. And then this last one that just, I'm sure there could be more, but a social understanding of just how you interact. Some kids are better at playing with others. So does the theory of mind just basically lump everything together, or is it, or does it not? And then you're trying to see how much these skills when you're young correlate to the older age skills,
Yeah, that's a great question. So this might become clearer when we talk about measurement, but the short answer is theory of mind is really the primitive to the things you're describing. So theory of mind is the ability to understand other people's mental states. And because you understand other people's mental states, you then may have more successful interactions, or you may build better social skills, play more nicely with your friends, or get on with your colleagues once you're an adult. Similarly, regarding empathy, if we think about effective empathy, your ability to kind of experience someone else's emotions, theory of mind presumably will be an input to that, because to be able to sort of experience someone's emotions, you're going to have to understand their state of mind. But we're really thinking of theory of mind as the basic skill that potentially leads to all of those other outcomes and behaviors.
Okay, so basically would it be, okay, I am a human, I feel these things, this other thing in front of me is a human, I see this other human must think and feel the same things as me, and then is it basically just that?
You don't necessarily have to think about them feeling the same things as you. It's more about, can you understand their feelings?
Okay. Yeah.
Now, there's a question of how you figure that out. You may have literally a model of the other person's brain in your head. I think that's why this is called theory of mind. It may be more a simulation-based approach where you put yourself in the other person's shoes and you think through you doing that situation. And that's more like you're saying that you would then kind of experience their state of mind by putting yourself in their situation. So we don't take a stance on kind of the cognitive process that underlies the ability to understand someone else's emotions. Psychologists write volumes about this, but I think have very little evidence. But in any case, theory of mind, just think about it as the basic ability to understand someone else, which may lead to various sorts of behaviors, which could be strategic or could be social, pro-social. It could be about friends and life success, could lead to all sorts of consequences.
Okay, excellent. Thanks.
Welcome. Any more questions? Okay, so our experiment was ran on kids. We have a sample of 730 kids, and they were recruited from 5 schools in Santander, a region of Spain. The kids in our study age from 5 to 12, so we're actually going to be able to replicate that age gradient of strategic sophistication that's been seen in other studies. That's not really the focus of our study. Our study is more about thinking about how the cognitive skills affect the strategic behavior of these kids. Regarding the experiment itself, first phase, this is necessary given our questions, is to measure theory of mind and cognitive ability for these kids. In the second stage, the kids play a repeated competitive game. And in the third stage, they play a gift exchange game. I'll talk more about the design of these games in a moment, but the competitive game is to really measure strategic kind of, I'll talk, it make more sense in the context of the games, so I'll leave what they measure until I get to the games. So when we design lab experiments, for those of you who ever design lab experiments, incentives are very important. That's true with kids as well as it's true with students or with adults. So we incentivize these kids. The younger kids are incentivized with stationery and educational supplies. And what I mean by incentivized is depending on their success in these games, depending on their payoffs, they get more or less of the rewards. They get more or less educational supplies. Older kids have some notion of money, so we just incentivize them with vouchers, which can be used in a bookstore or used online. Otherwise, our procedures are very much the same as you would have with adults. The interactions are anonymized, and we read the instructions aloud, so everyone has a shared understanding of what's happening in this experiment. We'll probably work a little bit harder than you might otherwise do to make sure that kids are understanding what's happening, given these are kids who it might take a little more effort for them to understand these games and to be able to get useful data from them. Okay, so our tests, we test theory of mind, and as we said, theory of mind is the ability to understand the mental states of others. This is a good place to distinguish between first order theory of mind and higher order theory of mind. First order theory of mind is, say, my ability to, I would have first order theory of mind if, say, I'm able to understand, say, Carl's mental states. That would be first order theory of mind. I would have second order theory of mind if I can reason accurately about, for example, what Carl thinks about Stephen. So if I can reason about what one person thinks about another person, that would be second order theory of mind. Building up recursively, we can think about third, fourth, and higher orders of theory of mind. The first and higher order theory of mind maps to how we measure theory of mind in our experiment. We use something called the imposing memory task. It's something which was developed in psychology. We use a version of this that's specifically designed for kids. The way this works is the subjects are read a story, the subjects being the kids in our experiment. They're read a story about several characters interacting, and then they're asked questions about the mental states of the characters. So it might be a story about 2 kids playing, and one kid takes away another kid's toy, and then we're asked, what does the first kid think about the second kid? Is she happy or sad, or so forth? The questions in this imposing memory task measure both first order theory of mind and higher order theory of mind. For older kids, we measure up to fourth order theory of mind. You actually need some pretty complicated scenarios and questions to measure theory of mind up to that order. We also in the experiment measure cognitive ability, and particularly we measure fluid intelligence, which is the ability to solve novel problems using new information. This is not crystallized intelligence, which is about just kind of knowing stuff, like knowing what's the capital of Germany. Fluid intelligence is more kind of a problem-solving ability. We measure fluid intelligence using the Raven's progressive matrices, a pretty popular measure of fluid intelligence. This is a non-verbal measure of fluid intelligence. The subject's presented with a pattern with one piece missing from the pattern. Then they have a choice of 6 or 8 pieces, which could complete the pattern, a bit like a jigsaw puzzle. And they have to pick which of those 6 or 8 pieces correctly completes the pattern. So there are different Raven's tests according to age. So for the younger kids in our experiment, they do the colored progressive matrices test. And for the kids aged 8 or older, they do the standard progressive matrices test. Once the students have done these tests, we're going to standardize the test scores on theory of mind and cognitive ability. And this is important for correctly interpreting our results in a moment. So what we want to do is really get to the bottom of how theory of mind affects behavior. Now, as kids get older, their theory of mind improves, as we were talking about this gradient that's known from developmental psychology. Thus, to cleanly separate the age effects from the within cohort variation in cognitive skills, what we do is to standardize our measure of theory of mind within each age group. So in practice, this means take all the 5-year-olds, take their theory of mind scores, and then standardize them to have a mean of 0 and a variance of 1. Then move on to all the 6-year-olds and do the same standardization. The 7-year-olds, the 8-year-olds, and so forth. Keep repeating that up to the 12-year-olds, so we have age-standardized theory of mind. We do the same thing with cognitive ability. This means that the average value of theory of mind and cognitive ability will be 0 at each age point, which means we've completely taken out the age effect from these cognitive skills. A key question here is about what theory of mind measures that is not already part of cognitive ability. If people who are good at cognitive tasks, if they're good at the Raven task, also are really good at the theory of mind task, in other words, if we have a high correlation between scores on those two tests, then potentially theory of mind is not measuring anything different from the Raven score. If it is measuring something different, it's not something we can empirically distinguish. It turns out that actually we have a pretty small correlation between the age-standardized theory of mind scores and the age-standardized cognitive ability scores. Quantitatively, we have a correlation of 0.28 between our two measures of these different skills. I think this provides evidence that the two tests are really capturing different skills, and there's potentially quite a lot to be learned from studying theory of mind above and beyond what we learn from just using more standard measures of cognitive skills like fluid intelligence. Carl. Maybe that's
you mentioned before that this has been heavily studied in the psychological literature. So I'm wondering if did you check whether they made before standardization, did they make sense relative to what other studies had found, perhaps?
In terms of this correlation?
Yeah, in terms of correlation or just the patterns in the data. Did the test throw up things that looked bizarre relative to what people had found in other fields?
Yeah, so the Raven test is really heavily studied, and that test scores look kind of what they should do. These kids, they're a bit more advanced. I don't know, the Spanish school system pushes these kids on a bit faster than in some other countries, so the kids are a bit further ahead for the age than you'd expect from kind of international comparisons, but it's in terms of the age gradient and the distributions, it's exactly what it should be. The imposing memory task is a specific task, is not that well studied, but we have broader evidence on theory of mind. Again, the age gradient that we see is really in line with that. The correlation is kind of interesting. So there are lots of studies in psychology which have pretty small samples, and that's because psychologists will typically recruit their own subjects and bring them into their own lab, and there's a limit to what you can do as kind of a sole operator of a research lab. And there are lots of these psychology studies that conclude there's zero correlation between theory of mind and cognitive ability. Actually, someone's done a meta-study, they put together all those studies, and they find pretty similar results to what we have, a modest but also statistically significant, that 0.28 is statistically significant correlation between the two skills. So I think, yeah, overall these skills look like what we'd expect for this population.
Great, thanks.
Yeah, always good when you collect there's a hugely strong psychometric testing, so you definitely don't want to be reinventing that or getting something that's inconsistent with the literature. So that's an important issue. So first of all, I'm going to talk about the gift exchange game. And I'm going to tell you the rules of the game and then move on to our results. So subjects in our experiment played this gift exchange game a single time. The way it worked is we'd randomly match the subjects together. They didn't know who they were playing against, but they knew they were playing with someone of the same age from the same school as themselves. So once you put the subjects into pairs, one person was randomly given the role of the allocator, and the other subject was determined to be the receiver. And the allocator and receiver here are going to face different decision problems. So the allocator has a pie of 10 tokens. They're technically super tokens because they're worth a little bit more than the tokens elsewhere in our experiment. And they have to split this pie of 10 tokens between themselves and the receiver. Once the receiver sees how much they've been given, they can decide whether or not they want to give one super token back to the allocator. Now, the interesting thing here is the allocator can't just choose any particular division of these 10 tokens that they want. Depending on the treatment they're in, they have two possible allocations that they can use. If they're in treatment A, they can choose between keeping 8 themselves and giving 2 to the receiver, or an equal split of 5 tokens for each person. In contrast, if they're in treatment B, the allocator has a choice between taking 2 for themselves and giving 8 to the receiver, or again, an equal split of 5 tokens each. What we're going to do, and I think this will be clear on the next slide when I get to the game trees, what we're going to do is we're going to look at the receivers who received 5 tokens from their allocator. Now, there are 2 ways you could get 5 tokens. You could get 5 tokens when you're in treatment A or when you're in treatment B. And the crucial thing is, if you get 5 tokens when you're in treatment A, the allocator has been pretty kind to you because they could have kept 8 for themselves. Whereas if you get 5 tokens in treatment B, actually the allocator wasn't being particularly kind. Actually, what they were doing was taking as much as they could for themselves, given the alternatives that are available. So the variation in treatment gives us variation in intentions of the allocators for receivers who are actually in the same situation. And I'll discuss this in the context of the game trees that we have here. So we have treatment A in the top right and treatment B in the bottom left. And these pairs of subjects are randomly allocated to be in either treatment A or treatment B. Now, if you're in treatment A and you're allocator, well, you have a choice between taking 8 for yourself or taking 5 for yourself. What we're going to do is to focus on the behavior of the receiver, or the receivers who end up in this situation here, where the allocator is chosen this equal split of 5 each, and the receiver has a choice between giving back nothing, in which case each subject ends up with 5 tokens, or alternatively, the receiver can give 1 back, in which case the allocator gets 6 tokens, and the receiver ends up with 4. The other treatment is treatment B down here, and that's a very big rectangle. Treatment B down here, the allocator's options are kind of different. They can either take 2 for themselves or take 5 for themselves. And again, what we're going to do is to concentrate on the receivers who receive 5 and to think about whether they give a token back or not. Now, the crucial thing is these 2 sets of receivers, they're actually in identical situations in the sense the payoffs are the same, the action sets are the same for them in this situation. Actually, the only thing that varies between these receivers in treatment A who've got 5 and the receivers in treatment B who've got 5 is the intentions of the allocator. In particular, in treatment A, if you're a receiver and you get 5, you see your allocator's actually been pretty kind to you. The allocator had nice intentions or kind intentions because the allocator here gave up the option of having 8 for themselves. In contrast, if you're a receiver down here in treatment B, you see, well, the allocator gave you 5, but what did they forego? What was the foregone alternative, the allocator? Or was actually a worse alternative to just take 2 for themselves? So in treatment B, we've got no particular information that the allocator was being kind. They're actually making a choice that is consistent with just them maximizing their own payoff. So in our empirical analysis, we're going to focus on the receivers in this 5-5 situation and see how the behavior of the receivers varies across treatments and how that response to the treatment varies with theory of mind and with cognitive ability. And that's what we do here. So these are results, I think, from a logit model, although we've now got linear probability models because our referees like linear models, which is allowed, I guess. And what we do is we run a logit model of and indicate that the outcome variable is returning this token back to the allocator. So we're modeling here the probability of giving back 1 token after you end up in this 5-5 split. And we look at how that varies with being in treatment A, in other words, having a kind allocator. In the first column, all we do is put in treatment A into the logit model along with intercept. So you see that if you're in treatment A, you're around 10 percentage points. These are marginal effects here. You're around 10 percentage points more likely to give a token back to the allocator. That effect's not quite statistically significant, but a kind of a benchmark. Second column, we just chuck in controls for age, theory of mind, and cognitive ability. All that stuff is by construction and correlated with the treatment, so it doesn't make any difference pretty much to the treatment effect. In the third column, this is where we have kind of the more interesting results. We have, again, these are marginal effects from a logit model. Explanatory variables are the treatment, age, theory of mind, and cognitive ability. And then the treatment interacted with age, theory of mind, and cognitive ability. And this is where we see some interesting results. First of all, I'll talk about the theory of mind results. We see if you're in treatment A, in other words, if you had a kind allocator, the higher your theory of mind, the more likely you are to return a token to the allocator. So the more likely you are to be kind of generous or kind yourself if you had a kind allocator as your theory of mind increases. And quantitatively here, for each 1 standard deviation increase in theory of mind, a subject in treatment A becomes 15 percentage points more likely to give a token back to the allocator. In contrast, cognitive ability is not having any significant interaction effect here with treatment A. We think this kind of makes sense because this is the situation here, the receiver is pretty cognitively simple. You just return or don't return. There's nothing much to understand. Whereas the subtlety of the intentions of the allocator are potentially much harder to understand. So we think it makes sense here. We find this interaction with theory of mind and not with cognitive ability. Stephen, go ahead. Is that a question? Just I don't hear anything.
Sorry, I had my microphone muted. So do you have, I guess, a theory, sort of like a Rabin reciprocity type of model in the background here that you're assuming that they're trying to figure out whether or not the other person is trying to be nice to them?
So we don't have a fully fleshed out model. So we're really thinking about this as response to intentions.
Yeah.
So it's slightly different from reciprocity. There's obviously overlap there, but it's not kind of a copy and paste reciprocity situation here. So, a simple reciprocity story would be like, the more someone gives me, the more I give back. And actually, maybe it's a good time to talk about the next slide. We do that on the next slide. So we just say, what's your probability of giving something back according to how much you were given? And how much you were given interacted with age, theory of mind, and cognitive ability. And we don't see any kind of interactions here. So we don't really have support for a simple reciprocity story. It's a more nuanced story where it's specifically the intentions which are driving the effect of the theory of mind.
Right. So the
In
Raven
terms of
theory
a more
actually,
detailed model than that, we haven't developed it.
so the Raven theory actually does say that reciprocity comes out of intentions to be kind, and it has sort of a specific way to sort of compute intentions, which I think sort of matches onto your game quite well here.
Yeah, okay, so we should look at that connection for sure. Yeah.
The reason I,
Yeah.
the reason why I asked about that model is that one of the sort of inputs to this sort of intention modeling thing in either the Raven or the Diefenberg and Kirchsteiger theory is beliefs about what the other person expects. And I was wondering if you had beliefs from the receiver about what they thought the first proposer expected back of them, and whether that correlates with theory of mind.
Yeah, so we haven't measured beliefs in this paper anywhere. So that would be interesting. It's sort of, I'd have to think about how that connects to theory of mind, because theory of mind is this a general ability to understand other people's mental states, and I don't know how to think about a belief elicitation in the context of kind of limits on theory of mind. But yeah, that would be an interesting kind of development you could do. But yeah, in terms of this design, we don't have any belief information. I think I'm literally showing you everything from the experiment.
I guess Ji Young also had a...
Yeah, Ji Young.
Oh, yes, I just have a really simple question. So when you showed us the game tree, for the first person, you actually use particular word take, right? So for allocator. So did you actually use this word when you explain this game to children, or this is just you, when you draw this game tree, you just use this word take?
So we used the experiment was administered on like tablet computers, and we had various sorts of graphics to help people understand. So there was like a picture of a table with 10 kind of tokens on it, and they could see the possible divisions they could use. I have to admit, I do not speak Spanish, so I do not know offhand exactly which word we used for the roles in the experiment. I could check that out and whether it was equivalent. But I think the key thing here is we worked pretty hard to make sure they understood. But did you have a question about the language?
Yeah, because in experiment, I mean, if you use the word give or if you use the word take, it's totally different game, right? So I think you need to check which word you use.
Yeah, right. Yeah, I should. That's a good point. Yeah, so we should check that. And yeah, so I think it definitely affects how we interpret like the baseline kind of giving back behavior. I got a feeling we made it pretty neutral. Like you can return, even that's not completely neutral, but you can return a token. But I will double check on that, and I think we should have something in the paper on that to explain how the game was presented. Okay, so that's what we're saying. In summary here, we're saying in this game, theory of mind predicts responding to intentions, doesn't predict simple reciprocity. And I think I've explained that. So that's the end of our gift exchange game. That's the first game from the experiment I'm going to talk about. The other game that subjects played in the experiment is what we're going to call the 1/6 token request game. If you know your experimental game designs, this is actually a cheaper variant for the experimenter, at least, the 1120 money request game, which Rubenstein has used. And The reason we're going to use this game is it allows us to make a really easy connection to the level K model, which I'll explain in a moment. So, rules of the game. And the way this is played again is two people in a pair. It's a different pair to in the gift exchange game, and actually going to play this 1/6 token request game several times over. Each time they play the game, they're going to be rematched, no feedback, so we can just think about these as repeated single shot plays of the game. So rules of the game, we're told, and again, this is in Spanish, and this is the English translation. Your partner and you are going to ask for an amount of tokens. The amount must be between 1 and 6. I will give you the amount of tokens that you ask for. However, I will give you 10 more tokens if you ask for exactly one token less than your partner. How many tokens are you going to ask for? So your head's probably spinning at this point, and we have some materials to help explain this game, but I'll give you some examples of how this works. Well, if you ask for 6 tokens, you get 6. And there's no way you can be exactly one number less than your opponent, because 6 is the max, so you just get 6. If you choose 5, you get 5 for sure, and then if your partner chose 6, you're going to get an extra 20. If your partner an extra 10. If your partner chose anything else, you'll just get that 5 that you asked for. So we've got a very strong incentive here to be exactly one choice lower than your opponent. In this game, there's no pure strategy, Nash equilibrium. There's a mixed strategy, Nash equilibrium, that places some weight on the kind of intermediate numbers here. We don't think it's very natural. The subjects are going to be playing the mixed strategy, Nash equilibrium. They're not getting any feedback. They're only going to play this game, I think, 7 times in total, so it's not like they could have learned the mixed strategy Nash equilibrium. So to interpret the choices in this game, we're going to exploit the fact that this game was designed to trigger level K reasoning, and we're going to cast our interpretation in the context of that level K model, but I'll touch on some alternative interpretations of our data as well. So what is a level K model, and how does it apply in this case? So you see some pretty fancy applications of a level K model. In this particular game, we can use a level K model really simply because the behaviors match exactly to the discrete choices in the game. So the level K model has players who are different levels of strategic sophistication, ranging from a level 0, who's the most unsophisticated type of player, to a level 1, who's one level more sophisticated, a level 2, who'd be one further more sophisticated, and so on, up to many higher orders. From the previous literature, we think that there's a limit on kind of how many levels that we see empirically, and maybe 5 or 6 is kind of the max number of levels of reasoning that kind of typically exist out there. People who are more sophisticated than that are probably playing the Nash equilibrium or doing some other kind of behavior. So what does a level 0 do? Level 0 is the most naive kind of player. They choose, in general, something which is instinctive and salient in the context of their choice situation. In this game, we think the obvious level 0 choice would be to choose 6. If you just think about how can I maximize my own payoff, don't think about anything to do with the other person, well, you choose 6. That guarantees you the highest possible payoff. What does a level 1 player do in general? A level 1 player assumes everyone else is level 0, and they think about how to maximize their payoff against the level 0 players. This means a level 1 is going to best respond to a level 0. In the context of our game, a level 0 chooses 6. So what does a level 1 do? Well, they want to go exactly 1 lower than the level 0. So a level 1 person will choose 5. And then it carries on recursively. A level 2 assumes everyone else is level 1 and best responds to that. In this game, a level 2 thinks everyone else will choose 5 because that's a level 1 choice, so a level 2 will choose 4. Of course, if you're kind of one step ahead of my discussion here, you'll have figured out that this cycles round, and eventually we get to high enough levels that the how does it work, about the level 6 or 7 choice will be to choose 6, the same as a level 0. Empirically, we don't think there are many of these really higher level types, so we can allows us to map the level 0 to a choice of 6, the level 1 to a choice of 5, and so forth. So in this particular game, we have very simple identification of level K choice rules from the choices that people make in the game. So subjects are going to play this competitive undercutting 1/6 token request game 5 times to start with, in the format I've just described to you. They're rematched each repetition, and they're told that they're matched with someone from the same school, but the person they're playing against could be any age up to 5 to 12, from 5 to 12, so anyone in the school who's in the experiment. So this means that everyone in the same school is facing the same distribution of opponents. In these first 5 repetitions of this game, the subjects are given no information about either their own test scores or the test scores of their opponents. So first of all, what do choices look like? This graph shows you choices along the horizontal axis, 1, 2, 3, 4, 5, 6, and the proportion of subjects making each choice on the vertical axis. So we've got around, it's fairly uniform, it's more uniform than I would have expected, maybe because we've got kids here. So we see that almost 20% of people choosing level 6, that would be our naive level 0 choice. And we've got around another 20% of people choosing 5, which is our level 1 choice. What we're going to do in our empirical analysis is to relate choice behavior in this game to theory of mind and cognitive ability. And what I'm showing you here in this table is marginal effects from a multinomial logit model. The current version of the paper, again, has results from some form of linear models, and everything looks pretty much the same, so you can sleep soundly tonight. On the vertical axis, I had the choice in the game, 1, 2, 3, 4, 5, 6. Underneath that, just because it's kind of gets difficult to keep everything in your head, I show the level K choice rule for each choice. So choice of 6 is a level 0, choice of 5 is a level 1, and so forth. And the next line is kind of interesting. What we're showing you is the expected payoff for each choice that you can make. And this is computed given the empirical distribution of choices in our experiment. Of course, if you choose 6, you get 6 for sure, and that's independent of what anyone else is doing. So that's choice of 6 maps automatically to an actual and therefore expected payoff of 6. Choice of 5, given the empirical distribution of what everyone else is doing, gives you an expected payoff of 6.8. So you're actually doing better off with the level 1 choice than the level 0 choice. Then it gets kind of interesting. If you become what the level K model would say is more sophisticated, so become a level 2 type, your expected payoff actually decreases. Your expected payoffs continue to decrease as we get to these higher level K choice rules. So it's not necessarily in this game that the higher level choice rule, what we would call the more sophisticated choice, in the sense you've reasoned through more levels of reasoning, actually gives you a higher payoff. Actually, the most sophisticated thing to do here, if you want to make as much money as possible, would be to choose the level 1 choice, even if potentially you're capable of higher levels of reasoning. So what are we going to do? We're going to look at these marginal effects here, and the effects are not super strong, I have to admit, in this specification, but we have some alternative specifications that either the effects hold up or they become a little stronger. And in general, maybe this is a good time for me to say, I think none of these parts of this paper answer all the questions we want to know about theory of mind and economic behavior. We kind of view it more as like a body of evidence taken together. I have 1 star here, so this is the bit where I like to say that part. So what do we see here? Theory of mind is increasing, although it's borderline significant, your chance of being a level 1. So people with higher theory of mind as compared to the level 0, so people that are able to do some form of strategic reasoning, are actually more likely to choose the payoff maximizing choice, and they do that by actually moving away from these really higher level K choice rules, which we think are cognitively more sophisticated. In terms of cognitive ability, higher behavior on the higher scores on this Raven test, move you away from being the naive kind of person and move you towards the level 1 choice rule. So here in this game, this competitive game, we're seeing that both theory of mind and cognitive ability are driving behavior. And again, in the context of the game, we think this makes sense. In particular, this game requires, to do well, both theory of mind and cognitive ability. So you need theory of mind because you need to think about what the other person is going to do. And you need cognitive ability to think about how to best respond to what the other person is going to do. In contrast to the gift exchange game, which is actually a pretty simple choice, return or don't return, the choice here is that we've got a choice of 6 different things, and you have to figure out this point about being exactly 1 less than the previous person. There's some cognitive demands here that were not really present in the gift exchange game, and we think that's why we see cognitive ability playing a role. But like the gift exchange game, doing well also requires you to think about what the other person is going to do, and that rationalizes, we think, the effect of theory of mind that we see here. This graph just shows you some age effects. This is really to match up with the literature. We show you the fraction of level 0 and level 1 play according to age. And what we see is the fraction of level 0 types is gradually going down to almost 0 as the children get older. And actually, if we play this game with adults, and we get that from the literature, we didn't do it in our experiment, you see very few level 0s among adults. And that matches up with what we're seeing here for the older kids in our experiment. This goes back to we want to make sure we have a validated kind of experimental design and that the behaviors in our experiment kind of match up with the literature. And we think we're seeing that based on this graph. Another variant of this competitive game we play is something we call the Raven game. And it's the same game, the same 1-6 token request game where the subjects are matched into pairs. And in this case, the subjects are given information about the cognitive ability of their opponents. In particular, each subject's told whether their opponent's Raven test score, their cognitive ability test score, was in the top half or the bottom half among subjects of her age. So you're basically told whether you're playing a high or low cognitive ability opponent. This creates exogenous variation in beliefs about the strategic sophistication of the opponent. It's exogenous because the subjects were randomly matched into these pairs. So in the case of adults, we have some evidence from previous work that people respond to this information about the cognitive sophistication of their opponents. So we wanted to look at this with children. And what we find is if we look among the older subjects in our experiment, this is kids who are aged about 8 and older, we do see some response of behavior according to the cognitive ability of the opponents. So in this graph, we're showing the distribution of choices if you face a low cognitive ability opponent on the left, and if you face a high cognitive ability opponent on the right. And just eyeballing this, we can see that we have, when you face a high cognitive ability opponent, this big spike at a choice of 4, which would be the level 2 choice rule in the context of the level K model. We don't see any such spike when you're playing a low cognitive ability opponent. So qualitatively, what this is showing is being told that you're facing a high cognitive ability opponent is making you shift towards level 2 choice rule. And remember, just to reiterate, this is just among older subjects. We don't see any such response among younger subjects. That shift to the level 2 choice rule is statistically significant. That's what we're showing you again, what we're showing you here in this picture. So we are seeing some significant shifting around of behavior in response to information about the cognitive ability of your opponent. And we think this matches up pretty well with our earlier results. So we showed that higher cognitive ability makes you more likely to be a level 1 type. And we're now told, well, if you know your opponent is high cognitive ability, then you're presumably going to think that person is more likely to be the level 1 type. And you yourself, therefore, should make the level 2 choice because that would be the best response to a level 1 type. So we think this is evidence of the emergence of a strategically sophisticated theory of mind, people using their cognitive ability together with their theory of mind to adjust appropriately to information about the ability of their opponents. And that's what that slide says. So that concludes what about the data from the experiment. If you have any more questions on that, I'm very happy to take them now or at the end of the talk. In the absence of questions, I'm going to move on to our study of theory of mind from the longitudinal data. So what we want to do here, having shown that theory of mind matters for strategic behavior among kids, is to extend the study of theory of mind to link theory of mind in childhood to adult outcomes. And like kids are great and all that, but ultimately personally, I'm interested as an economist in understanding kids because they're going to be adults making kind of big stake economic decisions in their adulthood. So I'm really interested in whether these skills established in childhood are actually important for later life outcomes rather than just being some facet of the childhood experience. So for this purpose, we're going to use a birth cohort study. Britain is a kind of world leader in birth cohort studies. This particular study is called the ALSPAC birth cohort study. ALSPAC is an acronym here for the Avon Longitudinal Study of Parents and Children. Avon, as I probably don't need to tell you, a region in the southwest of England, including Bristol, parts of Somerset, parts of the south of Wiltshire, and parts of Gloucestershire. I could get into the ins and outs of what Avon is and isn't, but just think of it as a geographical region. This study, the ALSPAC study, recruited pregnant women in this region who are expected to give birth between April 1991 and December 1992, so a 21 month period. The cool thing about these dates that we're going to use later is this actually covers 3 different school years. So the school year in the UK starts in September. So we've got children born who are going to be starting school in 3 different cohorts. These kids were born, and then ALSPAC collected information about the mothers, the families, and the cohort members themselves. And they've done that very, very frequently throughout childhood and into adulthood. So they have a very rich database of information. Among all the, and they say one thing that's kind of distinctive about the ALSPAC study is it has a stronger medical influence than many of the other cohort studies in the UK. So they bring the kids to clinics and they'll take various sort of physiological measures like blood pressure and even blood samples in some cases, and they also administer various sorts of medical tests and also some psychological testing, and that's actually what gives us our measure of theory of mind. So when these kids were around age 8, they were tested at one of these clinical sessions using the Danver test. So the Danver test of theory of mind is a childhood facial expressions test. So this is a different way of measuring theory of mind from what we did in the experiment. If you recall in the experiment, we read the kids' stories and asked them questions. What we're doing here, or not we're doing, but what ALSPAC did here is to give a visual test of emotion recognition. So the way the facial expressions test works is the kids are presented with a sequence of faces, a whole face from above the head down to the neck. Each face displayed an emotion, I think happy, sad, angry, or fearful. And the kid was asked to identify the expression being shown in the face out of the 4 alternatives that were listed. And they showed a number of these different faces. The faces of children, I think they're actually child actors who were asked to display different types of emotion. So our measure of theory of mind is just a child's score on this Danver childhood facial expressions test. It's pretty similar to what you might have seen something called the eye gaze test, which was developed by Simon Baron-Cohen at Cambridge, originally for researching autistic children, autistic people, but it's been used outside the literature on autism fairly extensively at this point. The eye gaze test does something very similar to the childhood facial expressions test, except it would show just the eyes and not the whole face. But the same idea, it's trying to measure theory of mind through pictures of faces or parts of faces. Meanwhile, the ALSPAC also measured cognitive ability. It's measured here using the WISC-3. The WISC is the Wechsler Intelligence Scale. There are various different iterations of this. It's been improved and developed over time. The WISC-3 was the state of the art in the mid-1990s when these kids were measured for their cognitive ability. So we standardized theory of mind and cognitive ability to have mean 0 and unit variance just to scale the effects that we get out of our analysis. And we have a correlation here of 0.21 between theory of mind and cognitive ability, which is pretty similar to what we saw in the experiment, as we talked about, pretty similar if we aggregate over the literature in psychology. So what do we do here? It's pretty basic in this first part. We have theory of mind and cognitive ability at age 8, and we're going to relate that to various adult outcomes. So we've got social skills, which is just the number of friends, fertility, number of kids, labour market behaviours, which be wages, employment, and whether you work in a big firm. And we have all those things that the last time they were surveyed in our ALSPAC data set, which is typically around age 23 to 25, depending on the outcome being measured. We also have information on education. Whether you're in education at 17 and 20, which is in the UK, so I don't need to explain the nuances of this, but being in education at 17 would be carrying on the education beyond what was the compulsory required age of 16 at this time. Being in education at 20 is typically being in a university kind of education. We also have an indicator of whether the kid obtains an A level, which is obviously the typical university entrance qualification. And what we're going to do is regress each of these outcomes on childhood theory of mind and the cognitive ability. And we've been very worried about various sorts of confounds here, like the kids who have good cognitive ability, maybe have parents who are earning higher incomes, or they live in better neighborhoods, or they have fewer siblings, or whatever it is. And the same with theory of mind. There could be various social demographics which are correlated with theory of mind and also potentially impactful or correlated with the adult outcomes. So fortunately, the ALSPAC birth cohort study is very rich, giving us huge amounts of information about the environment of the child. And this allows us to include controls for many aspects of the environment of the kid. So we're going to construct a rich set of controls, all based on information about the child's environment up to age 8 when we measure the theory of mind. So in particular, we're going to control for the kid's gender. The girls in this study tend to have slightly higher theory of mind than the boys, although it's not a really striking difference. We control for various maternal characteristics like age, education, occupation, household characteristics like income, spending on childcare, number of books owned, some neighbourhood quality information. We also have school characteristics, the characteristics of the primary schools that these kids were in at age 8, how big the school is, the class size, if it was a state school or a private school. All of that is thrown in as controls in this analysis. So that's our methodology here. Jump in if you have any questions. The next 4 slides are going to be showing the effects of theory of mind and cognitive ability on these adult outcomes. Remember, we've standardized theory of mind and cognitive ability to have a variance of 1. So these are all effects of a 1 standard deviation increase in the skill. First up, social skills. And we talked a little bit about whether theory of mind is the same as social skills earlier. We really follow psychology literature here and thinking theory of mind is something you have when you're very young, and then through various interactions with your friends and your families and your peers and your colleagues, that's going to determine the size of your social network. And in particular, I think if you have good theory of mind, you're better able to understand other people, to respond to them appropriately, to do things that please them, and therefore you might have a more extensive social network. So here we're regressing our measure of social skills, which is the number of close friends self-reported by the subject at, on average, age 24 and a half. We regress the number of close friends on theory of mind, cognitive ability, and that battery of controls we went through on the previous slide. We see a 1 standard deviation increase in theory of mind, increases the number of close friends at 25 by 0.2 of a friend, compared to a benchmark of around 7 friends. Also increases the chance of having 10 or more close friends by 2 percentage points, which is a form of robustness check here. Cognitive ability is also having significant positive effects on social skills. And actually, the effects here of cognitive ability are similar in magnitude to the effects of theory of mind. And that's kind of interesting, I think, because cognitive ability is something that a lot of papers have studied, and there's a huge amount of effort that's been put into looking at differentials in cognitive ability, effects of cognitive ability. Theory of mind is much less studied in terms of how it's affecting these adult outcomes, if at all studied. And yet we're seeing here similar magnitudes of effects for these 2 skills, maybe pointing to an important role or a greater importance that should be attached to theory of mind going forward than has previously been the case. And I see that Carl has a question.
Yeah, sorry, it's a bad question, but I'm just thinking that dependent variable has 2 things in it. It's the number and the closeness. so it's quite hard to interpret, isn't it? Like, how do you define closeness, and is that what these variables affect? How people think of who's a close friend or not, or is it the size of the social network, as you say?
I totally agree, and self-reported, big picture here, self-reported measures of these kind of pretty subjective things are really really not ideal. And I think the people who do like friendship networks, they'll look at they look at one-way and two-way friendships. You report who's your friend, and you check that person reports they're your friend, so you have like some match on there. And indeed, you can imagine a situation. I got a good theory of mind, so I understand that like the people I associate with aren't really my friends, whereas someone with bad theory of mind might not have figured out that these people aren't really your friends. So it is what it is. There's a totally valid point.
No, I just thought it was interesting. Yeah, especially the cognitive ability one.
I think it would. I'd be curious to see like an analysis of theory of mind where you have like a richer measure of the social network with more kind of objectivity or more detail in what you're measuring, because I think there are definitely effects that could go multiple ways. I mean, one way you can use theory of mind is through basically being able to exploit other people. If I can understand other people, I know how to manipulate them and get what I want. That doesn't necessarily mean you're going to end up with a lot of friends. So this is. It's very partial.
Okay, thank you.
Okay, so that was social skills, education, maybe a little more objective. We've got indicators of being in education at 17, and all of these, I didn't say, all of these life outcomes things are just from OLS regressions. So we've got being in education at 17, this is a linear probability model, same thing for being in education at 20, and an indicator for having an A level. And these are measured on average at age 18, 21, and 21 again. So we see some positive effects of theory of mind on education. So a better theory of mind is associated with being more likely to stay in education beyond what's compulsory, more likely to move on to a tertiary education, and more likely to get the university entrance qualification. As we'd expect, I think it'd be crazy if we didn't find this. We find strong statistically significant effects of cognitive ability on all these educational measures. And here the cognitive ability effects are bigger than the theory of mind effects. And I think that makes sense. And I would be kind of shocked and in a state of disbelief if we're finding that theory of mind is equally or more important for education than cognitive ability. But we're showing here that although cognitive ability is, if you like, the first order effect here, there is still a significant and quantitatively important effect for the theory of mind on top of cognitive ability in explaining these educational effects. You might wonder why we see these effects. There's actually a literature in psychology, which is more contemporaneous, linking current theory of mind to kind of educational outcomes of kids. And that kind of speculates that better theory of mind means that you can better understand what the teacher is trying to tell you. And that could be something which is important for the learning process. It could also come through teamwork with your colleagues, that if you've got a better theory of mind, you can work with your friends or your classmates and you get more out of the educational experience. Next thing we've got is fertility, and this confused me for a while until I thought about it more seriously, and I think it makes sense. So we have significant negative effects of theory of mind and cognitive ability on the probability of being a parent, and this is at around 26, and on the number of kids that you have at 26. I think what's going on here is really just a knock-on effect from the educational effects we saw on the last slide. There's lots of evidence in labor economics that, aside from what we're doing here, just in general, that people who stay on longer in education, they delay fertility, so they start their families later. And given we're looking here at fertility outcomes at age 26, I think what we're seeing here is the theory of mind has meant that you're more likely to stay on longer in school, getting A levels, potentially going to university, and that's going to potentially mean it's less likely that you've started your family by age 26. We obviously have to wait and see to what happens to these people kind of over the complete life cycle. And I'd speculate that the theory of mind is probably just shifting the timing of fertility rather than actually affecting fertility in total, completed fertility over the life cycle. But have to wait another couple of decades to figure that out for sure. The last effects we see are on the labour market, and we're not seeing much here. So for theory of mind, we're finding no effect on employment. This is age 24, 25, no effect on the log wage, a little bit of a positive effect on a large workplace. Some effects of cognitive ability, although not on employment, a little bit on wages, but it's small compared to what we expect about returns to ability. And again, an effect on the large workplace, but not a massive one. I think what's going on here, and again, I'm going to say basically we need to wait longer to see kind of the full picture, is that wages are pretty compressed in the UK for people at the start of their careers. Maybe because it's pretty hard to fire people, I'm not sure. But typically when people leave university or when they enter the labour market, maybe at an early age, there's not massive differentials in terms of wages. But as people become more established in their careers, we see more differentials, more heterogeneity in wages emerge. So it may well be that we see effects of theory of mind and bigger effects of cognitive ability once we're able to follow these people into the future. Indeed, given the effects we've seen on education, I think it would be kind of peculiar if we didn't eventually see theory of mind being associated with at least higher wages. Maybe not the employment rate, but at least higher wages. So we think really here there's a mandate to potentially follow these people further and figure out what the longer run effects of the education, greater educational attainment is in terms of employment and wages. The last part of the paper is really turns to this question of what we can do potentially in childhood to improve theory of mind. So there's a big literature mainly initiated by Jim Heckman thinking about early childhood interventions and what skills these early childhood interventions like better daycare or home intervention programs, for example, can have on children. And Heckman's emphasized the effects of these programs may operate through non-cognitive skills or soft skills or character skills, or whatever you want to call them. But that literature has not thus far pulled out a role for theory of mind. So what we're going to do here is have some pretty speculative evidence. We don't have a long panel and a huge sample, but we have some early indicative evidence that perhaps school spending is something which can potentially improve theory of mind in childhood. And what we're going to do is exploit the combination of the fact that we have kids spread over 3 different school years, so 3 school cohorts of kids, with the fact that in the late 1990s, early 2000s, when these kids were in primary school, there was a big expansion in primary school and also secondary school spending in England. This is partly a new Labour effect, but something that actually slightly predated the Tony Blair's Labour government. Basically, there were massive increases in funding for kids in state schools, which is the majority of kids in our sample, like more than 50% increases over a fairly small time span. To think about how to use this variation, we need to understand a little bit about how schools are funded in England. So the way it works is each state school is in a local educational authority, or LEA. Most of the money the school gets comes via the LEA. In particular, the government gives a block grant to the local educational authority, and then the local educational authority distributes that money among the schools under its management. The grant that the LEAs receive comes from central government through some formula, which has a lot of historic stuff in it and weird stuff in it. It isn't like particularly related to the here and now of what's going on in that particular local educational authority. So it's a kind of a peculiar way of funding schools, but what it generated was different increases in school funding across these 3 different cohorts of children across the different LEAs in our samples. There are a number of different LEAs included in the ALSPAC catchment area. Those different LEAs experience different increases in funding and actually different time trends of increases in funding, allowing us to do a difference in difference across LEAs and across school cohorts. So that's what we do here. Our outcome variable will be theory of mind at age 8. And we're going to look at the effect of school spending in thousands of pounds during the first 3 years the kid is in primary school, so age 5, 6, and 7. So we're looking at whether spending more in the primary school at age 5, 6, and 7 increases theory of mind measured at age 8. So first of all, what we do is with all kids, so the overall effect here, and finding a borderline significant positive effect of school spending on theory of mind. Now, ideally, these school interventions or any kind of early childhood interventions does something to reduce inequality and to, in particular, to increase the attainment of children less advantaged or at the bottom of the distribution in some way, and motivated by that, we split our analysis by advantaged and disadvantaged participants. The advantaged participants who are kids whose parents are in the top half of the income distribution for their school, so you've got rich parents for the school, and disadvantaged participants, they're kids whose parents are in the bottom half of the income distribution for their school. And what we see is, intriguingly, but maybe somewhat disappointingly, is the advancements in theory of mind are really among kids from richer families. So if your family is richer than average for your school, the school spending worked to improve theory of mind, and quite significantly so. Whereas if you were from a poorer family, among the families in your school, we find no significant effect and a close to zero magnitude of effect on theory of mind. So we can speculate about why we're seeing these effects on theory of mind, and I just see as a question, so I'll take that before I get into the weeds. So Stephen, go ahead.
Hi, yeah. So this being in the top half of the income distribution in your school, are you seeing this as just coming from the fact that these are high income kids, or is it really about the relative position? That is, have you looked at doing this, but just looking at absolute income rather than relative income?
We have not done absolute income. So we split it this way within school because we want it to be orthogonal to the variation we're using for the identification, but that means it doesn't speak to this question of absolute versus relative. So, I mean, we're just splitting it 50-50. We're not pulling out like the top 1% or anything. So I think probably a large part of this is absolute income differences, but we can't.
Yeah, no, I'm just curious because I guess there's some, sociological literature about the kids needing to fit in with sort of the reference group at their school, and I guess if you are sort of in the wrong reference group relative to your school, then the school getting extra money to educate you doesn't really work because you're not really attached to the school.
Yeah, I mean, I think, yeah, that could well be what is happening here. It could also be that these disadvantaged participants, their school spending that came was just extra money, so maybe they were in programs that were more focused on improving their cognitive ability or something else. So it could be that because they're at the bottom, maybe they're not in the right group to get advantage. This particular intervention, maybe they're getting something else. We can't really distinguish between those things. I mean, I think it's just, if you think that the disadvantaged people are potentially in some way behind, or that we particularly want to extra spending to target families who have less income, it's a little bit, for whatever reason, a little bit disappointing that we don't see the response in that group.
Yeah.
So we might, in general, wonder why on earth school spending could potentially be increasing theory of mind. One way to get at that is to look at what this money was spent on. And we can't do this school by school, but we can look over all schools. The vast majority of this extra money went on people. So either went, about 40% of it went on teachers, is 40% of the extra money. 20% went on educational support, admin, and clerical staff. A lot of that is something called educational support assistants. So these are typically unqualified individuals, at least not qualified teachers, who are kind of an extra person in the classroom who will give a bit of extra support to the teacher, maybe do some small group activities or work with particular students who have particular needs. So overall, like almost 2/3 of this extra money is going on extra people. And since theory of mind is a lot about understanding other people, you might think that having additional people in the classroom or extra people in the schools is something that could potentially be beneficial in terms of fostering theory of mind. Stephen, did you have another question?
Oh no, sorry, I just forgot to lower my hand.
Okay, no problem. So yeah, we don't have a huge time span here because we just have the 3 cohorts and we just have one particular region. So this is kind of indicative evidence or suggestive evidence. It would be nice to have further evidence on ways that we can increase theory of mind, and particularly look at interventions that could target less advantaged children. So the last couple of slides just to conclude. So what have we done in this paper? We think we're complementing existing work that aims to improve cognitive skills in childhood. Particularly, we're highlighting theory of mind as a skill and one that's not received attention from the economists previously. We've got some evidence that school spending can even increase that particular cognitive skill. In terms of the experimental analysis, we've got some new evidence potentially giving a reason for non-equilibrium thinking. So the level K model is one particular model of why people may not just be playing the equilibrium. We have some form of limitations on strategic sophistication. In this paper, we're linking this to theory of mind, potentially giving some kind of opportunities to give a greater grounding to why we have bounded rationality and limited sophistication in economic behavior in the laboratory. We also complement existing work in psychology that tries to train kids to improve their theory of mind. I haven't talked about this in detail, but there's a lot of psychologists who will get a group of kids in, measure their theory of mind, do some small intervention, measure their theory of mind again, all in the space of like 30 minutes. So it's very much teaching to the test. The sort of theory of mind interventions they might look at is reading a story with a strong emphasis on characters, or teaching people to read expressions or read faces. It's very much kind of training people to take the test. So we think we potentially have an intervention through school spending. Well, expensive is one that could potentially give longer term, more externally valid manipulation of theory of mind. So finally, we hope these findings will lead to more research on theory of mind and economics that potentially takes more seriously the ability of people to understand the mental processes of others, learn about how theory of mind is driving behavior, and think about interventions that could improve theory of mind. There's more to be done on this in experiments, and ultimately, once ALSPAC have done their great work in following these cohort members through their lives, we can potentially look at even longer term impacts of theory of mind on life cycle behaviors. So that's all I wanted to say. Thank you very much for all your questions and discussions, and I'm happy to take any more questions or say goodbye if we're all done at this point.
Victoria, thanks a lot. I think Carl left one comment. Carl, would you like to talk about this?
Yeah, I'm not sure which one you might mean now. Do you mean the one about the employment regressions?
Yes, Carl, you mentioned about the dependent variable of cumulative earning by age X.
Yeah, sorry, Victoria. It was just that I missed whether your adult observations were snapshot or multiple observations adulthood.
Oh yeah,
so
good
I wonder
question.
whether you could combine them so you get sort of a cumulative earnings or something. Combine the hourly wage and the employed variables.
Yeah, so ALSPAC followed these people multiple times in adulthood, which is why you see some things are at 24, some at 25.
Yeah.
What we've done here is to take the last time we observed each of these outcomes. This is employment the last time we saw it, and the wage the last time we saw it. But for some of those people, they will have also answered an earlier survey, so you could do something more longitudinal.
Yeah.
You do get people jumping in and out, so you have to be kind of mindful of that. And I'm also a little nervous about going back too far because you start to get mixed up with education. You want to by
Sure.
age 24, at least in the UK, I think most people would have completed the education. So we don't have any kind of selection on that margin with people not working because they're studying.
That makes sense.
So I will say the strong comparative advantage of the survey is probably more on the biomedical and testing stuff, and the labour market outcomes data is there, but it's not as rich as some of the other stuff. So it's done by questionnaires instead of in the post instead of getting them in. So it would be nice if they could, do like a understanding society type survey, but it's not great, I would say.
Was there no occupation of any kind?
Well, so yeah, good question. Occupation 23, they have it, but it's they coded it in a non-standard way.
Right.
They use a description of the occupation, but there's kind of a standard way to do that to get into the occupations. They didn't do the standard thing, I think, because they're a bit outside this literature. So it didn't make it into the paper, but I can tell you anyway. So we distinguish kind of high, middle, and low occupations. Low being kind of manual, middle being kind of administrative, technical occupations, and the higher being like professional things, like a lawyer or a professor or a full doctor. And actually, theory of mind seemed to be, and this is like takes it a grain of salt because of the measurement issues, seems to be like increasing your chance of being in this middle occupational group. And you might speculate that includes things like sales and probably teaching and some kind of a lot of occupations where you're kind of skilled enough that you're working with other people rather than just like assembling something or doing kind of a routine thing, but you're not super high like a doctor or whatever where you're kind of making a lot of your own decisions. So there might be a little bit of effect on the middle of the occupational distribution very coarsely, but I didn't feel good enough about the data to put it in the paper.
Okay.
And that could potentially explain why we're not seeing a wage effect, because there's more of a hump shape effect going on here, but that's kind of getting into the realms of speculation. Does Colin have a question?
Yes, thanks very much. My question is, do you have any intergenerational correlation to show us? I mean, I would have thought that theory of mind in an individual child or whatever is pretty closely associated with parental theory of mind. Does your data give us any insight into that at all?
The ALSPAC data set, which isn't all the data I have, you sort of request the little data set you want. ALSPAC did measure theory of mind of the parents.
Right.
So at one of these clinics, when the kids came in, when they were kids, the caregiver comes with the kid, and then they took the opportunity to collect the theory of mind from the parents. We've not looked at this, so we kind of control for all the kind of demographics of the family, but not the parental theory of mind. I don't know whether or not that's been looked at in the literature or not. So you'd see I suspect you see a strong correlation. Whether you'd have a strong correlation once you control for like the parental income and education and so forth. That's an empirical question. It'd be an interesting one, but, and one you could answer with the ALSPAC, but we've not gone there.
You're saying ALSPAC doesn't give you any guidance there? No.
No. So you could order the data from them and look at it. That's totally feasible. What ALSPAC tell you is for each variable, they show you just its marginal distribution. So I could look at the distribution for the mothers and for the kids, but I can't relate them without ordering the data set.
And if I may, another question, which I think you may have already answered when talking about your experimental work. Have you detected any differences in theory of mind determinants or theory of mind levels, differences due to ethnic, racial, ethnicity, anything like that at all?
So in the experiment, the Spanish kids, I don't think we have anything like that. In the ALSPAC, there is that information, but I don't think we'd be powered to do a great study. So these kids are from the Bristol area in the 1990s, so its vast majority will be white.
You're right. The majority would be white, but I mean, it's interesting you should you specifically mentioned Bristol, where I guess that, compared to the sort of national average, you've got a pretty high ethnic minority population there. And that might be interesting if you could tease that data out.
Yeah, right. So that we do have, and we could look at that. So the only kind of demographic we've done would be gender, which is obviously not what you're asking. And there's a bit of a difference there. So, and there's certainly heterogeneity overall. So I haven't got the answer to it, but it is knowable.
Okay. Thank you.
You're welcome. I'm running out of time, so I don't see any more hands. So maybe it's a good time for me to say thank you for all your questions and discussions. It's very nice to have an interactive seminar, even though we're all so spread out from each other. So it's been a pleasure being with you today.
Yeah, Victoria, thank you very much. I really enjoy your talk. And I know that a lot of my colleagues have kids which age between 5 to 12. So one day I will invite their kids and then we can run level K game.
Yeah, no, I can see there's a temptation to experiment.
Yeah. Thank you very much. Yeah.
You're welcome. It's nice to talk to everyone. Thank you for inviting me.
Yeah. Thank you.